Welcome to The Explainer. So, today we're diving into a cosmic mystery that is literally tearing up the rulebook of astrophysics. We're looking way back to the dawn of time, right after the Big Bang, and we're finding things that, frankly, have no business being there. We're talking about colossal, universe-breaking structures. It's wild, and it's forcing us to rethink everything we thought we knew about how the cosmos evolved. Think of this as the ultimate cosmic whodunit. If you were to draw a simple stickman animation of the early universe, you'd probably just sketch out these tiny, gradual beginnings, right? Like small clouds of gas slowly forming little baby stars. But instead, we are finding fully formed supermassive structures that existed mere hundreds of millions of years after the Big Bang. So the huge question here is, how on Earth did billion-mass black holes form when the universe itself was basically just a baby? Okay, let's dive into this. To really ground us, we need to look at our smoking gun, the Infinity Galaxy. Now, this is not your standard, serene, spiral galaxy. No, this is a violent, incredibly unusual system. It features two highly compact galactic nuclei, totally surrounded by these massive ring-like structures. But the real kicker here? There's a supermassive black hole that isn't just sitting neatly in the center of either galaxy. Instead, it's literally suspended in this vast reservoir of gas. All the evidence points to a massive head-on collision between two disk galaxies that triggered this totally chaotic architecture. And let me tell you, objects exactly like this one are causing a massive headache for astronomers. Section 1. Breaking the Standard Universe. So, for decades, pretty much 99% of established cosmological models relied on this idea of slow, hierarchical growth. The standard model basically posits that galaxies formed gradually through localized accretion. Think small clouds gathering slowly with a really low efficiency for actually converting that gas into stars, usually around 20% or less. But then, the James Webb Space Telescope came online and wow, it is completely upending that entire narrative. JWST is finding highly complex, ultramassive structures forming incredibly rapidly, just 500 to 700 million years post-Big Bang. The sheer volume of these impossible anomalies is just staggering. It's a whole roster of rule breakers. First up, there's JWST's quintet. This is an ongoing, super compact merger of at least 5 galaxies, and they're forming stars at a blistering rate of 250 solar masses a year. Then you have the red monsters. These are 3 ultramassive galaxies converting gas to stars at nearly twice the normal efficiency. And finally, the aptly named universe breakers. These are 6 candidate galaxies from that 500 to 700 million year window that contain up to 100 times more stellar mass than any model predicted for that epoch. I mean, one of them is as heavy as our modern Milky Way, but 30 times more compact. And this brilliantly illustrates the sheer absurdity of the situation we're in. As Dr. Eduardo Bañados from the Max Planck Institute for Astronomy put it, and I absolutely love this, it's like discovering a full-grown adult in a kindergarten class. You just do not expect to see these mature, heavy giants hanging out in the infant universe. They simply shouldn't have had the time to grow this big. So, the crucial point is exactly how massive these objects really are. 6 billion. That is the solar mass of a completely dormant black hole located in a galaxy called MRG M0138. Astronomers were actually able to weigh this invisible behemoth from 10 billion light-years away. They used JWST combined with gravitational lensing, which is basically where a foreground cluster of galaxies acts as this giant natural magnifying glass. That let them measure the speeds of stars swirling around the black hole's immense gravitational grip. 6 billion suns just sitting there. Section 2. Born Big. Direct Collapse. Now, what's really interesting about this is how these cosmic giants managed to completely bypass billions of years of evolution. Just look at the stark contrast in these mass ratios. In our local, modern universe, a central supermassive black hole is usually way, way smaller than its host galaxy. We're talking a ratio of about 1 to 1,000. But in the early universe, JWST found systems where the ratio is literally 1 to 1. The black hole is basically equal in mass to all of its host stars combined. This absolutely destroys the idea that these early giants grew gradually by just munching on stellar remnants over billions of years. Instead, theorists like Dr. Priyam Vadanatarajan are proposing something radically different. They weren't grown, they were born big. This is the direct collapse black hole theory. The idea is that under very specific primordial conditions, vast, pristine clouds of gas gather. But instead of fragmenting into smaller, normal stars like you'd normally expect, the entire cloud collapses wholesale, just all at once. This instantly creates massive black hole seeds starting at 10,000 up to 100,000 times the mass of our sun. They completely skip the slow stellar life cycle. And actually, this brings us right back to the infinity galaxy. Remember that suspended black hole we talked about earlier? It isn't sitting in a galactic core because it likely formed through this exact direct collapse process. The incredibly violent head-on collision of those two disk galaxies forced dense, turbulent gas to just collapse directly, triggering the birth of a supermassive black hole right there in the gas reservoir. It's basically a smoking gun for this incredible, violent phenomenon. Section 3. Hearing the cosmic hum. Let's move to and see how this builds a completely different picture. Because the early universe isn't the only place we're finding clues. We are now actually finding auditory evidence rippling right through our present-day cosmos. The Nanograph collaboration, which was founded back in 2007, basically spent 15 years turning our entire sector of the Milky Way into a galaxy-sized antenna. How? By continuously observing 68 millisecond pulsars. These are ultra-dense, rapidly spinning dead stars that tick like hyper-precise cosmic clocks. And in 2023, they announced they had detected a subtle change in these ticking clocks, revealing a low-frequency gravitational wave background, essentially a cosmic hum permeating the entire universe. So, what is actually causing this hum? I absolutely love this analogy from Dr. Changpei Ma at UC Berkeley. She says the black hole's orbital dance prior to merging vibrates spacetime analogous to the way waltzing dancers rhythmically vibrate a dance floor. Just imagine that for a second. Billions of these supermassive black hole pairs spiraling around each other across the entire 13.8 billion year history of the universe, their combined ripples overlapping like pebbles tossed into a giant pond. And this hum? It actually solves a huge headache in astrophysics known as the last parsec problem. See, when galaxies merge, their central supermassive black holes sink toward the center, right? They get within about a kiloparsec, which is roughly 3,200 light-years of each other. But theorists just couldn't figure out how they closed that final tiny gap without stalling out forever. Well, the nanograph data is the proof. Those background vibrations prove that a large fraction of these supermassive giants absolutely do overcome the stall, successfully coalescing and pumping out these massive gravitational waves. To really put the sheer scale of this into perspective, we just have to look at the difference in our detectors. Ground-based interferometers like LIGO and Virgo catch high-frequency gravitational waves. These are quick, tiny chirps lasting just fractions of a second, and they're generated by stellar mass black holes, maybe 30 solar masses or so, colliding. But nanograph? It's detecting low-frequency waves that take years or even decades to complete a single oscillation, and they are driven by inspiraling supermassive black holes weighing hundreds of millions to billions of solar masses. We are quite literally listening to the heaviest monsters in existence. Section 4. Future Eyes on the Sky. So we have visual proof of impossible giants in the past, and we can actually hear their echoes today. But this story is far from over. We are standing right on the precipice of a golden age in astronomy with next-generation observatories. Just look at these breathtaking specifications. The Webb Space Telescope, launching in late 2026, is going to park 1 million miles away and sport a 300-megapixel camera with a field of view 100 times larger than Hubble's. And down here on Earth, in Chile, the Vera C. Rubin Observatory is seeing first light in 2025. It houses the world's largest digital camera at 3.2 gigapixels. It is literally going to scan the entire visible southern sky every 3 to 4 days, giving us an ultra-high-definition time-lapse of the universe. With these tools coming online, the hunt is going into absolute overdrive. We're not just looking for static images anymore. We're going to map out the invisible scaffolding of dark matter through weak gravitational lensing. We're going to track the terrifying force of dark energy that's accelerating the universe's expansion. We'll even be able to catch live tidal disruption events, which is literally watching supermassive black holes rip apart and devour stars in real time. And absolutely crucial to our story today, these massive surveys are going to find thousands of new gravitational lenses, helping us spot even more dormant supermassive black holes lurking in the early universe. Which brings us to the ultimate question. We found the infinity galaxy, this violent crash site of direct collapse black holes. We've heard the gravitational waltz of merging giants vibrating through the very fabric of space-time itself. The old models are totally broken, and our universe is clearly far wilder than we ever sketched out. So I'll leave you with this. If the universe is already humming with the echoes of impossible giants, what else is hiding in the dark, just waiting to completely shatter our understanding of the cosmos? Keep looking up and stay curious.